Hello, Professor. My name is Rashid Osho, and together with my colleague, Hasib Kamran, we shall be presenting our report on maximizing residential energy efficiency through grid-tied solar system optimization in Pakistan. Introduction. Energy is vital for socio-economic development, and the UN's Sustainable Energy for All initiative strives for global access to electricity. Globally, we know that demand is surging, which is predominantly met by depleting fossil fuel, and this leads to environmental issues like greenhouse gas emissions and the climate change. Researchers all over the world have always advocated, and they are still advocating, for renewable energy sources like solar, wind, geothermal, hydropower, and biomass due to their abundance and their environmental benefit. Globally, data available to us shows that the building sector is responsible for 30 to 40% of global energy consumption, which emphasizes the need for policies regarding energy conservation, particularly in residential buildings. Pakistan, which is a focal country for this research work, faces an energy crisis with a growing demand-supply gap, and solar is proposed as an effective and environmentally friendly solution to address the demand-supply deficit. Project objective. The objective of this work are: one, to investigate the electricity generation sources in Pakistan; two, to investigate the electricity generation generated and the low demand, we want to see the gap; three, to investigate the reason for the deficit in generation in supply of electricity; and finally, we want to design effective solar power generation and integrate it with the grid for use in residential buildings so as to bridge the gap between demand and supply. Site description. Marpur city in Pakistan is an area of research work and is situated between the latitudinal coordinate of 33.11 degree to 33.34 degrees and the longitudinal coordinates of 73.31 degrees to 73.55 degrees, and features a topography that includes plains and foothills of the Himalayas. The population of Marpel was 456,200 in 2008, and the city covers an expansive area of about 1,000 square kilometers. Marlborough City experiences a climate with a maximum average temperature of around 40 degrees Celsius, while the Mangla Hydroelectric Power Station supplies electricity to Marlborough through a 132 kV, that's kilovolt transmission feeder. This same Mangla Electricity Power Station supplies about 35% of the Pakistan electricity demand, and so it's very important to the economy of Pakistan. Marfa demand for electricity has notably increased, of course, in uh, in the same trend with the global increase, as evidenced by the presence of over 92,000 domestic electricity connections recorded in 2018. Present energy scenario in Pakistan. Next, we're looking at the present situation in Pakistan with respect to generation and consumption of electricity. If you look at the figure 2, the one on the right, we'll see that thermal power plant contributes 62% to the global total generation, while hydropower plant contribute 26% to the annual generation. Renewable here, we have other renewable contributing 4%, nuclear is contributing 8% to the generation of electricity in uh, in Pakistan. To my left hand side, we have another figure which shows that the building sector contributes about 55% of the total consumption. If you look at it, we have a combination of residential and commercial, which gives about 55% of the total consumption. And if you compare this to the other countries, especially developed countries of US, we see that it's far higher. US we have 39% coming from the building sector. Canada has 27% coming from the building sector, and China is just 20%, while in Pakistan is 55%, which is far higher than what it is in the countries that I mentioned. In 2018, electricity usage in residential building accounted for 46% of Pakistan total, reaching about 41 terawatt hour, while the commercial buildings contributed 8%, and that totaled about 6.5 terawatt hour of electricity. Next, we shall be looking at electricity challenges in Pakistan. Electricity challenges in Pakistan. Well, we see that despite the abundance of energy sources in Pakistan, which could be used for power generation, unfortunately, the nation still continues to grapple with energy deficiencies. Between 2005 and 2004 and 2005, the per capita electricity consumption in Pakistan was 425 kilowatt hour, which is significantly lower than the world average. That's the global average of approximately 2,500 kilowatt hour, which represents almost six times less energy consumption in Pakistan compared to the rest of the world. In 2013, the total energy supply amounted to 64.5 million tons of oil equivalent. And see that despite the fact that Pakistan is generating 16,000 megawatts of electricity, which was generated in 2013 to 2014 period, the country still faced a substantial electricity shortage due to a rising energy demand, and this leads to a minimum of 6 to 8 hours of power outage on a daily basis. Next, we look at the renewable energy potential in Pakistan. Question is, does Pakistan have enough renewable energy to, bridge the gap between the demand and supply of energy? The answer seems to be positive, as Pakistan possesses substantial potential for various renewable energy sources such as wind, hydro, solar, biogas, tidal, geothermal, and biomass. Table 1 shows us the estimated renewable energy potential in Pakistan. For solar, estimated capacity is about million, uh, 2.1 million megawatt. Wind is about 349,000 megawatt. Biogas, 3,000 megawatt. Hydro, 2,000 megawatt. Waste to energy, 1,000 megawatt. We can see from this table that Pakistan has enormous amount of renewable energy potential that can be harnessed to solve its energy crisis. Next, we're looking at the solar energy. Of course, solar energy produces power directly, with the use of PV panel at the point of demand. Hence, is beneficial for use in remote or grid area. Pakistan, as we gather from data available, has an average daily radiation of 5 to 7 kilowatt hour per meter square on an over 95% of its land mass, with a high persistence factor exceeding 85%. That is massive. Of course, we also see from available data that the solar energy potential in Pakistan is estimated at 2.9 million megawatts, with over 300 sunny days in a year, which is good. And of course, global irradiation of between 1,900 and 2,200 kilowatt hour per meter. Let's look at the hydro power. The main water source of Pakistan is the Himalaya watershed, with glacier and snow melt. Surface water is only available from the Indus River and its major tributaries. Of course, we also gather that Pakistan also has three western rivers, the Chenab, the Jhelum, and the Indus, with an annual mill discharge approximately 173 billion cubic meter, which is massive, and that Pakistan has an estimated hydro potential of over 40,000 megawatts. But unfortunately, it's only about 6,500 megawatts that is being exploited presently. Wind energy. Pakistan experienced an average wind speed of between 5 and 7 meters per second in the coastal area of Sindh and Balochistan provinces. Research available tells us that Pakistan holds over 20,000 megawatts of economically viable wind potential. And of course, the coastal area, especially the Karo in Sindh, demonstrates significant wind potential with an average wind speed exceeding 7 meters per second at a height of 50 meters. It is also estimated that the exploitable electric power generation from wind in Sweden is conservatively a minimum of 11,000 megawatts, which is quite massive. Mathematical modeling, mathematical methodology and mathematical modeling. The approach employed focus on deploying grid-tied solar systems for enhanced household energy efficiency. It also utilizes the Homer Pro for a systematic design process considering location, load design, and equipment lifespan. It also optimizes the configuration using the Homer to ensure efficiency over the system life cycle. Emphasis here will be on economic metrics such as the net present value, payback, and the levelized cost of electricity, which you want to keep as low as possible to make the proposed system economically viable. My colleague will take the remaining part of the presentation. Thank you.
Hello, I'm Asif Kamran, and this is the schematic diagram of the entire project. This is a grid-connected solar power system that will run a residential house in Pakistan, and specifically in Mirpur. We have the grid, the electric load, we have the solar panels, the converter, the batteries. This is the solar GHI data of Mirpur, Pakistan. So as you can see that the annual average kilowatt hours per meter square per day is 5.24 in Pakistan, right? Which is significantly more than in Canada. So in Pakistan, the solar panels will generate more power as compared to like Canada and some other colder countries. So which is more beneficial for our residential solar powered system. This is the temperature data of our selected location. So as you can see that June July is the hottest days in the entire year. So for the air conditioning, so in these months the most amount of load would be required. I studied a research paper in which multiple houses in Mirpur city were analyzed. So 523 houses in Mirpur were analyzed, and the average household household load was 2,469 kilowatt hours, which is annually. And if you convert it like in a day, so this is 6.81 kilowatt hours per day. And this is a family this is a average house for a family of 7 in Pakistan, and has a floor space of 78.91 meters square. So this is like the average house in Mirpur, which has a family of 7. So for the solar panels, we selected Canadian Solar Max Power CS6U 340M, which is a 340 watt solar panel. And the dimensions are written here. And we selected this solar panel because it was reliable, it was efficient, and it had a cheaper price point of $279.5. So that's why we selected this. When we wanted to choose a power converter, so the peak power of our load was 1.45 kilowatts. So that's why we selected a 2 kilowatt power rating converter, which is the Studer Extender XTM 2000-12. So this is a good power converter which is reliable, and uh, it has a good power rating. So for the batteries, we chose a 12-volt lead acid battery, which is the Enersys PowerSafe SBS XC190F. So this was a relatively cheap battery, which cost $703, right? And we chose a string size of 4, which makes the total voltage 48 volts. And as you can see, like in the results, we'll show you like the number of batteries which were used in the actual system. As you can see from the cost analysis, that the total cost of the system is $11,285, right? And from the above figure, the capital cost is almost like $9,000, and operating cost is negative because this is a grid connected system. So like sometimes we are buying energy from the grid, but most of the time we are selling energy back to the grid. So that's why it is negative, and the replacement cost and the salvage cost. So overall, this cost of the system is $11,285. So when we did the simulation on Homer Pro, so as you can see that the solar panels, the Canadian Solar, made 6,282 kilowatts hour per year, which is almost 83.3% of the entire energy generation. And we purchased 1,257 kilowatts hour per year from the grid. right? And as you can see from the consumption data that we sold 3,852 kilowatt hours per year to the grid back, right? So this is the negative value, like we are getting money actually back from the grid sales. So this is really good, and this graph shows that shows the monthly electrical production. So as you can see that like June, July is the production is higher because of the solar radiations as well as like the load requirement. So these are all the calculations based on the simulation results. So the electrical generation from solar panels is 6,282 kilowatt hour per year. The grid purchases are 1,257. The grid sales are the following 3,852. And from the kilowatt hour cost in Pakistan per electricity, so that is 42.72 rupees. So we calculated the cost savings, which is 1,103 US dollars, which is annually, right? So when we calculate the payback period from this cost, so the payback period of this entire system is 10.2 years, and the system normally runs for at least 25 years. The solar panel lasts for at least 25 years. So our system will pay itself back in 10.2 years, and after that it's the system will like earn almost $1,100 annually. And you know, in Pakistan, the cost of electricity is going up almost every month, right? So this is the cost, the 42.72 rupees per kilowatt hour right now. But like after 1 year, this cost would be increased. So when we calculate the payback period after like 1 2 years, it would be even less. It would be maybe 8 or 9 years. So that's why this is really good to like install solar panels in Pakistan right now. So these are the grid results. So as you can see, uh, that the first column is the months, right? So the second column is the energy purchased, and the third column is energy sold. So if you focus on these two things, energy purchased and energy sold, right? So in January, 98.6 kilowatt hours energy was purchased, right? And 299 energy was sold, right? So and same is the case for the rest of the months as well, right? So as you can see, we only purchased 1,257 energy, and we sold 3,852 kilowatt hours back to the grid. So that's why the net energy purchase is in negative terms 2,595 kilowatt hours. So which is pretty good. This is causing like a lot of energy savings and like cost savings. So from these pictures, as you can see that the top picture is energy purchase from the grid, and the bottom picture is energy sold to the grid. So in the top picture, as you can see, the blue lines, right? So the middle part is black. As you can see that in the middle part, we are not purchasing electricity because solar panels are making the electricity. As you can see in the lower portion, the solar panel when solar panels are making the electricity, so we are not purchasing it. So as you can see from the black portions of both of the graphs, so these are actually like interdependent on each other. So that's what this graph shows. To conclude, the simulation of the grid-connected solar panels for Mirpur, Pakistan shows that in Pakistan it is really beneficial to install solar panels in our homes because the payback period is 10 years right now according to the current rates of electricity, but the electricity rates are going up each day, right? And with all the taxes and everything on the electricity, it is better to install solar panels now so that you do not face any power outages, right? And you can sell back energy to the grid as well, right? And like moving on to like if you look ahead in like 3 4 years, the payback period will be even less than this, right? So it is really beneficial to install solar panels so that you are not solely dependent on the grid. and you are making your own energy, and you do not face any like power outages. So this really highlights that like installing solar panel in Pakistan is really beneficial. These are all the references that we used. That is all from my side. Thank you very much, and I hope you have a nice day.